currently I work as a developer advocate at Couchbase. So for those of you who are not familiar with Couchbase, it's basically a document database that is highly performant and well suited for highly distributed applications. And last year in Couchbase, we introduced the possibility for you to run your machine learning models within your database. And so I took this opportunity to explore the machine learning capabilities provided by Couchbase and also provided by some of the other existing products on the market. So this is just a really high-level overview of machine learning. I'm pretty sure all of you know about this. So the idea is that a lot of these companies, they have a lot of data right now. And there is a lot of data that is being continuously collected from all the applications that we use. And they're trying to solve the problems or they're trying to get some meaningful value from these data. So there are things like personalized offers, for example, your taxi hailing apps, or you have things like coupons that are sent when they detect that you might be churning. Or there are lots more other examples like anomaly detection for credit card frauds and so on. And this is like one of the common workflows that you see in when you deploy a model. So you start with getting some training data, and typically your applications would be, data would be in transactional databases like Postgres or even like NoSQL databases. And you typically don't use the same databases for your analytical workloads because they're more time consuming and they shouldn't affect your applications that access the operational database. And so typically you have ETL jobs or extract, transform, and load jobs that take this data from the operational database and put it into your analytical databases. And then you have your classical feature engineering where you experiment with different features for the data that is stored in your analytical database, and sometimes you also create feature stores so that the features can be reused. And then you have the classic training where you run the machine learning algorithms or deep learning algorithms like support vector machines or random forest or neural nets. And then comes the process of deploying this model. And normally you tend to package this model by using a simple API framework like Flask or Fast API, and then build a small microservice around it, which is then accessed by your applications that are calling this machine learning use case. Well, the good thing is it works quite well, and you can also have a lot of flexibility in scaling your services and also doing whatever you like in the models. However, some of the issues that I've seen in practice is that you end up with a lot of duplication of data, especially when you have people who work on, let's say, local copies of the data and you do some experiments, then there's a high likelihood that you tend to deviate from the standard data in your operational database. And also, it's not a trivial job to maintain these ETL jobs, especially with all those fault handling and retries and all those kind of things. And also, updating these models or data is a combined effort of both the application team and also the data scientists or data engineers in most cases. So coming to some of the options that are provided by machine learning, options for machine learning in databases. So currently, what you see is the modern databases, they have adapted to the needs of the industry, and they are adding machine learning algorithms inbuilt into the database. For example, you have BigQuery or Redshift where you can directly call TensorFlow models, or even they also have a lot of custom, not custom, I mean, they have an inbuilt uh, support for a lot of the algorithms like support vector machines, gradient boost, and so on. Similarly, there are like third-party additions like MindsDB, which you can plug into your existing data, and they create like a copy of your data and then work on it. But it's completely invisible to you. Then you also have databases like SQL Server or Oracle or Firebase or Couchbase, where you have support for writing your own models for machine learning applications. And these are typically done in Python or R. One thing is, like in most of these cases, you would write your inference in terms of queries. Yeah, so as I explained earlier, so this is like a subset of all the algorithms that are provided out of the box in BigQuery. And yeah, it even supports importing like TensorFlow models. And the workflow is like you write a statement, create model, and you specify the parameters of the model. And you can just call select model with your inputs to get your inference. Yeah, with MindsDB, you have support for a lot of applications. But what they do under the hood is they create like a copy of your data, yeah, and they work on this. But you basically use MindsDB to create your predictor, and then, yeah, you basically do your inference in a SQL-like statement. And coming to the custom machine learning models, so in this case, the workflow is like you start building your model in your developer machines, mostly in Python or R. Then you create like a package, and then most of the cases you have like a custom procedure in the database, which is then calling this package. And yeah, the inference is also like SQL-like. Yeah, I'll show this in a demo. Yeah, but just to summarize, some of the advantages here is like you don't have a lot of variation between your analytical data and your operational data. And one more thing here is that your data doesn't leave the database. So this might be important in some, let's say, it's more for like legal purposes, like there are some laws for some data that they shouldn't be processed in certain areas. And yeah, it's also quite nice if you don't have data scientists to get some out-of-the-box models. And the model update path is also quite stable, so you just develop or retrain your model and then deploy it. And you won't need a microservice to deploy your model. I mean, there are some drawbacks as usual, like one thing you might want to keep in mind is that it might not be suitable for all models. Like, for example, if your model is highly dependent on GPU, maybe the inference is not that performant when using databases, because in most of the cases you don't use GPU in the database, although there are some databases that use GPU. Yeah, so with that said, I'll just do a quick demo using Couchbase. So how we do this in Couchbase is we have a concept of services. So you have like your data service, which is typically your data or like operational data, where you store your transactions. And then you have an analytics service, which is tracking your operational data in real time. So this is creating all those, or it is copying all the data from your data service, and this is also completely independent from your operational database. Yeah, and you can also scale this up and down however you like. And this is also like massively parallel processing, so depending on how many nodes you are running your analytics service, you get like that kind of linear performance. And yeah, you basically write your UDFs in Python for your machine learning. So I just want to give you like a real world example. So this is like a website that I found online. But what they do is like they take a few parameters from you, and based on that they give you a code for your insurance. And so I found like a data set on Kaggle which does which estimates the medical costs based on these features. I mean, it's like a really small data set, and it's just for like checking out what is possible. And yeah, so essentially you put values for all these features like age, gender, BMI, smoking status or region, and children. And based on that, you get like a estimated medical cost, and based on this, you can get your insurance code. And all this is done in real time. And this is a workflow that you do. So you train your model locally in Python, then you package it along with all the dependencies into a small package, and this is then deployed into Couchbase Analytics, and you create a user-defined function that would call this, that would be called in your SQL statements. Yeah, I'll just quickly jump to the demo. So this is like a simple query workbench where you can type in your query. So I already have some query, which is doing like an insurance estimate for someone aged 40, female, BMI and all. So let's just run it. Yeah, so you see that like within 1 second you have a inference which is saying that the medical cost is like 19,000 for this person for a year. This is not all, so you can also do this within your application. So I just built like a simple application, and here you can put in some values, yeah, and do like an estimate. So what is happening under the hood is this data is now getting stored into your into my data service, and then it is getting copied into the analytics service, and you are getting this inference $18,000, and all this is happening in like 11 seconds, which is quite fast. Yeah, and I can also show like the simple model. So the model is not doing anything, so it's just like a simple random forest with with encoding for the categorical features. Yeah, this is that, and you are just like dumping this into a pickle file, and here you are just reading this pickle file, and then there's a function that is just doing an inference. It's that simple. Yeah. So this was like a simple example. So I also tried like another example using deep learning. So one of the common use cases that you see is like real-time machine translation. For example, on Amazon, if you're accessing Amazon from a different country, you still get like the reviews from other countries, and you can also translate them to your language in your profile. The same thing happens on Twitter. So for example, you can see tweets in German, and you can click on a button and it gets translated. So this is something which is quite cool. And I said, okay, let's see if we can do it. And the good thing is, open source is great, so you have all these pre-trained models that are available on Hugging Face. So I just checked it out, and there is like a library which is the one which is used by Microsoft Translator, and it has support even for multiple languages, and it's like just 300, 400 MB per model, and there are over 1,000 models. So you could theoretically do this for any combination of languages. Like, yeah. And yeah, so that's what I tried to do. So I created like a simple application that would just get those messages and do a real-time translation. So let me just go back to the demo. So I have this running on my local machine, but you can also join this. So by scanning this QR code, if you like, and type in a message, and we can test this model. So let's just get some message. Yeah. I don't speak Lithuanian, so I'm just trying a translator. Let's see if it works. Yeah, this would take a bit more time, but hopefully it would work. Yeah. So let's just wait. in the meanwhile, if you like, you can try this. Yeah, so it's kind of accurate, I would say. I mean, although I don't know the language, but at least it's similar to what I typed in for the original. And yeah, if you are joining the chat, like I can also try to get some of the messages. So, I mean, this whole thing took like less than 20 seconds. Yeah, so, yeah, let's just try to get the last 10 messages. And if some of you have sent some message, hopefully we'll see it there. Yeah, let me just also show you the code that is doing this. So this is all that I had to do. So this is just a pre-trained model, and there's nothing out of the ordinary. Like, you just take this pre-trained model from, which is published by Helsinki University, and yeah, you have this text that you're getting from query, and you're doing a translation and returning it. Yeah, this is still taking a bit of time, but that's fine. Yeah, you can do the same thing here. So this is just like the query workbench like we saw earlier. So let's just test it with a different language. Yeah, German. Yeah. Oh, okay. There was a server error. Live demos. Okay, but let's see if this one worked. Okay. Wow. Let's see. Okay. Yeah, it's basically coming from the database. So maybe where there was just too much traffic. Let's see if we can see the data in the. Yeah. Okay. Yeah, I see some messages. So let's just try it once again. Ah, okay. I see what is happening. Yeah, so there was, yeah. The analytics service crashed for some reason. I mean, yeah. So as you can see on top, this is still like in a developer preview mode. Yeah. And this is like, we are still working on it. And there are like 1 or 2 edge cases where you could have these issues. Let's see if, yeah, so now it's back. Let's see. Yeah, let's try this. Okay, no, it's still not working. But you had to trust me, this was working. Yeah. But yeah, I mean, you get the idea that you do like, you can just create like custom models in Python, and you can run the inference directly using like SQL-like. I mean, it's not officially SQL. This is like quite similar to SQL. Yeah, we call it SQL++ because we are working on JSON documents, not like relational documents. And you can also access this using both like SDK in any of your languages, or there's even like a REST endpoint which you can use. And yeah, you can also scale just the service independently. Right now, all this is running just on my machine inside Docker. So this is like two CPUs, I guess, and like 5 GB of RAM. Yeah, but essentially, I can eliminate all the microservices that I have for deploying my jobs, and also get rid of ETL jobs, especially in this case. Well, to conclude, I would say machine learning is becoming more and more a part of your database architecture. Like all these big companies are providing support for them natively. And also there's a lot of support that is coming for like custom models, so not just models that are provided by the databases. But as you saw earlier, like what we did with the deep learning example is kind of on the border. Like it might not, it's quite heavy for something that you're running inside your database. Like the model is around 800 megabytes in memory, yeah. And yeah, this is all. So to summarize, I would say, if you are a company and you don't have like data scientists, maybe this is something you can use some of these algorithms out of the box. It works. And yeah, this is something which you should definitely consider if you're trying to run your machine learning applications. Yeah. And yeah, all the code is public, so you can find it on GitHub. Yeah, I'll also share the slides. And yeah, if you have any questions, please reach out. Yeah. And yeah, that's all. Thanks.